Well, hey, good afternoon. Hope everybody's doing well. Welcome to another training podcast event session from CRT Services. And we just want to thank everybody for taking the time this afternoon to join us. And we're looking forward to all the sessions we have coming up this week and the future weeks. Again, keep the ideas coming in. We've gotten a lot of good ones, and share the videos that we're posting up online. If you have suggestions for something, this week we're a little bit more intensive in the FlowX flow computer of things, but we're going to start doing some more general topics out there. So if you have suggestions, please let us know. And again, if you need anything, if you need any help, assistance, if there's anything that we can do, we hope everybody's safe, but reach out to us and at CRT Services. You can reach us on our website or at our emails, and we will give you any assistance we can. If you have questions about what we're going to go over, please don't hesitate to email us. And if we don't know the answer, we'll find somebody who does. Today's going to be a short topic because it's on FlowX Input Calibration. And what we're going to look at specifically is what do we do in the FlowX to calibrate the process variables coming in, whether that's analogs, whether that's digitals, or whether that's, let's say, meters or density meters or something else. What do we do for the calibration of those, and how does it affect the FlowX and our measurement inside of that? And it's pretty simplistic, and we'll go into detail of this, but with calibration, what we're doing is we're either checking a process input and verifying that the value that it says that it is what we're actually receiving. If we're not, then we're putting in, let's say, a calibration factor into it, or we're generating a calibration factor. But calibration can also be proving physical meters, so our proving routines can be calibration. It can be putting in a density correction factor for a densitometer, where the density correction factor has been derived by doing a hydrometer, a pycnometer, or off of a GC. So there may be a lot of different places where we're getting calibration factors and constants. We're going to go over where to put those in. So no slides today, just this one saying, hey, FlowX Input Calibration. And what we're going to do is we're going to go right into the FlowX itself. So I'm going to go ahead and log in, because with the FlowX, of course, we can't do anything unless we're actually logged into it. So that way we can record in the audit trail any calibration or parameter changes we've made. So it's timed out the session that I was previously in. I'm going to go ahead and log in. And what we're going to do first is we're going to go ahead and calibrate a analog input. And this is the most common calibration that we're going to do for process inputs coming into the FlowX. Now, different devices out there, flow computers, and specifically I'll talk about rocks, or let's say total flows, Thermo, the Autopilot Pros. They do calibration a little bit differently in the upstream world than what we typically do in the midstream and downstream world, where when
hey,
we,
Brett,
yeah.
Question. Are you sharing your screen with us?
Why, yes, I am. How's that? Perfect. Thank you. So with calibration, we'll go back into this real quick. What am I doing when I calibrate an instrument? Let's get specific, and we'll talk about a temperature transmitter. So with a temperature transmitter, there's a couple things that I'm looking at. Is one, I need to verify the temperature. So with that, I need to verify what my flowing temperature coming across is compared to the device I'm using to measure it. So whether that's an RTD that just is sitting into the pipe, or whether it's a transmitter that's actually giving me a 4 to 20 milliamp signal out, or it's giving me a heart, or it's giving me a 1 to 5, I'm going to calibrate the instrument that I have first. So with that, when I look at the transmitter, what I want to do is I want to first verify that value. So I'll put in usually a certified thermometer into a test thermal well, and then I'll verify what the thermometer reads compared to what the instrument reads. And I can do that either on the face of it, or I may use a handheld communicator to talk to the device. But if it says 65 degrees, I should say it says 65 degrees. Now, with temperature, and specifically with pressure, there may be a bunch of different ranges that we need to go through. So with pressure, a lot of times what we'll do is we'll take it to 0, and we may do a 3-point or a 5-point calibration, where I'm going to take it to 0 or 25%, then 50%, 75%, 100%. And we're checking those points along the way to verify what the instrument's reading versus what my calibrated device is reading. And then after that, I'm going to verify that against what the actual flow computer is reading. So in a total flow, when we do this, typically you're hooked up to the transmitter and you're supplying pressure to it. And you're doing it all through the total flow. So it's verifying the instrument. It has communications to it. And it's saying, okay, well, I've got 0 pounds and I'm looking at the total flow and it's saying 0.1 pound. So here is what I have. Here is what I'm actually seeing. And you enter in what you have. So my calibration parameter that I'm putting in is, my reference is 0, but I'm seeing 0.1, and you would record that by hitting a button on the total flow. And then you would step through and you would go through your different points and you would find your as foul. So here's what I have at 50%. Here's what I have at 100%. The FlowX, we don't do that. What we're looking at is what is the process variable coming into us. We want you to calibrate the transmitter, but we're not recording that within the flow computer. We have made some changes to our gas application, and we're going to be implementing them in the liquids application. But what we're going to be verifying here is we're assuming that you've already calibrated the instrument. Now we're going to be calibrating the process input, the 4 to 20 milliamp signal or the 1 to 5 volt signal. So with the calibration, when I say calibration, we're going to go into I/O, and I'm going to go into the module we want to calibrate, and I'll go into calibration. And the first thing I'm going to go into is settings. So with the analog inputs, we can have up to 5 points of calibration. So I'm going to calibrate 0, 50, 100, or I could do 0, 25, 50, 75, and 100, giving myself a 5-point calibration. If I'm calibrating PT100s, or let's say if I'm calibrating RTDs, then with the RTDs, I'm going to calibrate by temperature. So minus 50, 0, 100, but this is still a 3-point calibration. And then when I go into analog outputs, I'm going to set up and do a calibration of the analog output. And I'll explain that when we get to them, but I can also do a 5-point calibration. And what these calibrations are is basically we're saying, hey, listen, I know I'm supposed to be receiving 4 milliamps, but I'm not getting 4, I'm getting 4.1. And then when I go to 50%, I should be getting 12 milliamps, but I'm getting 12.3. And what we do is we put offsets in there and we use a linearization or a linearized calibration curve to actually offset those values. So if I just put in an offset, let's say that I look at my temperature and it's 60 degrees, but I'm reading 61 degrees. If I just put in, let's say, an offset of 1 degree, so take my 61 degrees that the instrument's giving me and decrease it by 1, that's not a linear curve. So just because I'm 1 degree at 60 doesn't mean that at 80 degrees that I'm still that 1 degree. I may only be half a degree or 0.25 degrees. So by just putting in a single offset in to offset the value, it's not a good calibration. It's not really doing a calibration. You're doing an offset of the value coming in. As we're here, we're doing a calibration of the loop, or if you're actually doing it on a device that can do the whole process, the whole temperature range, and 5 points on that temperature range, then it's putting in a linearized offset, which is a very difficult word for me to say. But we're going to keep everything pretty simple here, and we're going to do a 5-point calibration curve on an analog input. And the other thing that we have inside the FlowX is we have this calibration timeout. The calibration timeout, again, if I look at the I on here, it's going to tell me that it's part of the system calibration. And what the calibration timeout is for is once you place something in calibration, if you leave it and don't touch it for 1800 seconds, it's going to take itself back out of calibration. We put this in because we found that sometimes some people are doing calibrations, they get called to do something else, and they've left that process value in calibration mode, meaning that it's a forced input or we're not looking at the live input anymore. So we're going to put a timer in there and basically say, if you haven't touched it in 1800 seconds, we'll take it back out of the calibrate mode. So I'm going to go back up one screen. And what we're going to do is we're going to calibrate an input. Now with the calibration of the inputs, and I'm going to blow my screen up a little bit or actually reduce the size of it. And you can do that in a web browser by hitting the control button and then hitting plus or minus. So down the bottom, the FlowX, you'll see that we have 6 analog inputs. And we've tagged those for a reference to let us know that, hey, we're using these for temperature and we're using these for pressure. So to calibrate, what I'll do is I'll come up and I'll select which analog input I want to use. Well, I want to calibrate temperature, so that's on analog input number 1. And you can see that it's grayed now, and I haven't written these changes down. So I'm going to go ahead and say calibrate. And what this is going to do is this is now going to force that process variable to look at a certain reference value. So what I'm telling it is we have a 3-point curve. The first point on my settings was I wanted 0. Well, if this is a 4 to 20 milliamp transmitter, my current reference value is going to be 4 milliamps. I want to see 4 milliamps. This is what I should be seeing. But over here at my current corrected value, I'm only seeing 0 milliamps. So obviously I have a problem with my signal. But if I had 3.1, let's say 3.9, 3.98, I would want to recalibrate this point. So what I'm going to do is I'm going to hit recalibrate this point. And what this says is, it says, well, my reference is 4, I'm seeing 3.9. Well, that's actually 4, so I'm going to hit OK. And it's going to in turn say, okay, well, now it's 4. So I put an offset in there. But I put an offset or a calibration offset in there that is going to be used linearly across this calibration curve that I create. So the next thing I do is I'm going to hit next calibration step. And with next calibration step, since we said we're doing a 3-point curve and I'm going to be at 50%, it's going to ask me for 12 milliamps. Because if I have a 4 to 20 milliamp signal, that gives me 16 milliamps of total movement. Half of 16 is 8. My 0 is 4, so 8 plus 4 is 12. So now I want to see 12. I would go ahead and set the transmitter to give myself 50% of its output. And then I would look and see what my current corrected value is. Now, I don't have a live transmitter hooked up there, so it's still referencing what I said 0 was because it has 0 milliamps coming into it. So this would go to 11.9. I would hit recalibrate this point. I would hit the next calibration step, and my next calibration step is going to be 100%. So if I'm on a 4 to 20 milliamp loop, 100% is going to be, well, that's right, 20. So I hit next calibration step, and it's at 20. I hit recalibrate this point. When I hit next calibration step, it'll go back to the beginning. It'll ask me for 4. I'll verify my 4, and if everything's good, I'll go ahead and take it out of the calibration mode. And now it gets out of the calibration mode. Now, if I go to my audit trail over on the left-hand side, you'll see that the analog input 1 calibration changed from alarm to normal and from normal to alarm, letting you know that this was put into the calibration mode. If I still had something in the calibration mode, I'd also have an alarm up here saying that that analog input number 1 was in the calibration mode, and it would be red. But it's out, so it's green flashing, and green flashing in the FlowX means that I had an alarm. The alarm condition's been cleared, but I have not acknowledged the alarm. As soon as I acknowledge it, it will go away. So if I really messed up my calibration, I can always go back into the module and go into my calibration, go to my analog input, and I messed up the calibration on this. I had something wrong with it. So what I want to do is I want to restore it back to the factory. And I'm going to go ahead and apply that. I'll put it back in calibrate, and you can see the 4 says it's 4, but we know we don't have anything coming in, so that actually should say 0 milliamps. Well, if I hit the reset calibration to factory, that'll restore it back to the factory calibration. The last thing we have is if you want to freeze all the analog and RTD input values. So if I was doing a process and I didn't want that process to move because I'm changing these input values, we could freeze where they were or right at that moment in time. So that's all that means is freezes all analog inputs and PT100 inputs of the flow module. So it puts them into the freeze mode right then and there. So that's analog inputs. RTDs, we have 2 RTDs. So if you were to select an RTD, Again, we're going to do a 3-point. So we were doing -50, 0, and 50, I think it was. So right now it's 432 degrees on my RTD coming in, so it's pretty warm here. That's not really what I want to see. So what I'm going to do is hit recalibrate this point, and that will tell it, no, what you're actually seeing is 50. Now, obviously, if it was that far off, we're not going to calibrate it. These should be pretty darn close. If you see something that grossly out, then you've got an issue with wiring or an RTD or something in the FlowX. But just for testing and just for demonstration. Now I'm going to hit the next calibration point. That's going to be 0. I would change my resistance coming in to 0, and I would calibrate that input. And then I would hit next calibration point, and I'm at 100 degrees. I would make the change my resistance so I'd see 100 degrees, and then I would go ahead and hit recalibrate. The next calibration step will take me back to -50, and I'll verify that again. Again, if I've messed it up, then I can just always say, as long as I have the right one selected, reset this particular input back to factory, and that'll go back to the factory. And that's RTDs. The last thing we may have is an analog output. So we're sending an analog output to a PLC or some other device. We're driving a loop. So we're doing like a PID loop for pressure control and flow control. So we want to calibrate what we're saying we're giving out at 4 milliamps and what the output or what the device reading us is seeing it for, and also up to 20. So again, if I'm controlling a loop, I want to make sure if the loop can't be calibrated, let's say a variable control variable speed drive pump or VFD they call them, or a pressure controller, that they may not be able to calibrate on their side. If I'm sending 4, but they're seeing 4.1, they may not be able to make an adjustment. Well, I can make an adjustment by increasing or decreasing the output to actually give them what they believe is 4. And we put in that curve in there. So what I do is, this is an analog output, let's say for flow rate. I can go in and select analog output number 1, and it's going to go ahead, and the first thing it's going to do is it's going to give it 0% of span. So I'll look on my device now that I'm trying to calibrate, and it should be seeing 4 milliamps, and it should be at 0%. If it's off a little bit, I can hit the increase or decrease buttons, the amount of times that I need to increase the output enough or decrease the output. So if it was 4.1, I could hit decrease. That may change it to 4.05. I hit decrease again. That changes it to 4. Now that it's 4 perfect, I hit recalibrate this point, and that locks in that change. I hit next calibration step, and now I want to get 50% of scale. So if it was coming in at 4.98, and I would just hit increase once, now it's 4.99, hit increase again. Now they're telling me that, no, now it's 50%, that's perfect. I hit recalibrate this point, and that locks that value in. Next calibration step is 100%. And again, you can change these by going into the settings underneath the calibration screen and change the number of points you're doing. So if I wanted to do a 5-point curve, then I would go ahead and put in 5 different points that I want to calibrate at. I hit next step. I'll go back to 0. I'll verify that they're getting a good 0, and then I'll take it out of the calibrate mode. But if I wound up, again, wanting to I took it too far, something's messed up in the system, I want to start back over, I can always hit recalibrate to factory, and it will recalibrate it back to what the factory default was, and then we can go ahead and try again. When I'm all done, I'll take the output out, and I will say none. And that's pretty much it for the inputs and outputs of calibration. The other points that we have on calibration are typically our meter factors, and meter factors will be derived either by the FlowX improving, or it's by a third-party prover or another proving device, and then we're putting in a meter factor. So for the meter factors, we simply go into our overview screen, we go into the flow meter, and we're able to go in and look at our meter factors. So I have current values and our meter factor histories. So we can reset the histories of the last meter factors that we've actually derived inside the flow computer. And we can also see the current meter factor that's in use. and the last time it was proved if the FlowX is the one proving it. To actually change the factors, we have to go into configuration and into the run, and then we would go into the flow meter, and we would go into the meter factors, and you have both forward and reverse meter factors. So in this case, I only have one product meter factor. With the FlowX, you can have multiple products, so you may wind up having 16 different products, each of them with different meter factors, and we go ahead and put in the meter factor here. So if I change this to 1.0023, when I apply that, that will put in that meter factor for product one. And then when I go back into my home screen and actually go into the flow meter and look at my meter factor and my current meter factor, it's at 1.0023. So what this is doing is it's basically taking the indicated volume and it's multiplying it by this 1.0023, and that's giving me my gross volume. So gross volume is going to contain that meter factor inside of it. And that is the simple form of calibrations that we do inside the FlowX. We're not getting into how we're calibrating the actual instruments. We're going to do a couple short videos on how to do temperature calibration and pressure calibration. And when we make the changes to actually be able to do as founds, as lefts, as far as process inputs, we'll create another video where we can demonstrate how that's done within the FlowX. So are there any questions on the analog input or analog output or RTD calibrations? All right. Well, once again, I want to thank everybody for joining. We're going to go ahead and post this up here in a little bit, and it'll be online. And then tomorrow we'll have another couple sessions in the afternoon. So look forward to talking to you then. And again, in the meantime, if you have any questions or if there's anything we can answer, don't hesitate to give us a shout. And everybody stay safe out there. Thank you.